Okay, welcome back. For those of you who are just joining, basically my name is the Duke Dev, and what I'm doing is I'm following a book uh by a great developer who named Daniel Holden. The book is called Build Your Own Lisp. Uh, it's thematically a book about learning the C programming language having by having hands-on practice, basically. So everything is hands-on. There is no theory. There's not a lot of theory, at least, and you learn actually by doing, which is really good, which I prefer. So what we did in the last episode is we basically finished one of the chapters. I finished. What's this? Okay. I was using ChatGPT for some questions and answers. So basically, we finished one chapter, and now we are moving on to another one. So let me just. Oh yeah, I have another wallpaper. Let me just switch it around. It looks cool. I like it. Maybe not in this mode, but in the vertical one, it's really good. The problem with wallpapers for tablets is that the wallpapers are generally not as high quality as they should be, so they kind of they are kind of grainy and blurry at times. Okay, let me just create this way. Yes, this. Let me create a new, I don't know. So this will be chapter 11, and it's called variables. Okay, looks looks good enough. So before I continue, let me just do something else. No, I don't want to exit Vim. I need to open a separate window. I need to split it like this. Up. I need to split it like this. It's gonna be this. What do I have here? Okay, I need to copy chapter 10 MPC C MPC. Do I need to do this again? Yeah, I need to do this again. MPCH and coolexpressions.c to chapter 11. Then let me just move here and rename this to variable C. Okay, and then CC, instead of using coexpressions here as the name of the file, I'm gonna use variable C, and I'm gonna call the finishing script variables as well. I have a warning. Why do I have a warning? Let me first leave this. Go here. Variables.c. Why do I have, what line is this? 252. I think what I should do is I should delete this. Okay, I think it's okay now. So let's talk about variables. Now, what I like about this specific book is the fact that, okay, I'm still here. just gonna change the colors a bit. I'm gonna use this yellow. I'm gonna use this, I don't know, bright red one. Maybe this blue. Okay, so let's talk about variables. What do we have now? We build a pretty robust grammar. We build implementation of it. We have a structure in place called the Lisp value that is being manipulated on by our code. So we have a lot of goodies. Now let's talk about variables. So here it says, we are adding additional features that will make the language more practical. And the first one is going to be variables. They're going to be mutable, meaning that they cannot change. When we evaluate an expression, we have imagined that the previous thing has been deleted and a new thing returned. So what does this mean? So conceptually, what does this mean? The book says this. Our variables are immutable, meaning that they cannot change. Okay, why? Everything in our language so far has acted as if it is immutable. When we evaluate an expression, we have imagined that the previous thing has been deleted. Okay. So if we have an expression, whatever we set as an input doesn't exist anymore. We return a completely new value. So what will variables be, basically? Variables will be nothing more than just a way to name values. We will assign a name to a value and we will get the copy of this value later on. So we will assign a name. Oops, sorry, I'm writing. Assign a name to a value and get the copy. Get the copy of that value. Okay. So we need to implement this, and to implement this, we need to create a structure which stores the name and value of everything named in our program. Okay, so what I assume this means is, wait, I need to lie the tablet down like this. Okay, so what do we need? We need a structure. Yeah, this is a lot easier. So we'll most probably have something like this. That will store the name and the value of everything we have. I assume this is it. So we call this the environment. Okay, so this will be the environment. when we start a new interactive prompt, we want to create a new environment to go along with it in which each new bit of input is evaluated. Then we can store and recall variables as we program. Okay, so most probably every time when we run the application. So when I run the program, I assume we'll build we will build a new environment, right? And inside the environment, we will have our variables, and we can recall them and store them as we want. Okay. So there is a subsection here saying what happens when we reassign a name to something new. Isn't this like mutability? Which, by not even looking at what is written in the book, I don't think it is, because we are just resetting the name to something new, right? When we reassign a name, we are going to delete the old association and create a new one. This gives the illusion of that the thing assigned to that name has changed and is mutable, but in fact it's not, of course. Okay. Now that we're going to allow for user-defined variables, we need to update the grammar for symbols to be more flexible. Rather than just our built-in functions, it should match any possible valid symbol. Unlike in C, where the name of a variable can be fairly restrictive, we're going to allow for all sorts of characters in the name of the variables. We can create a regular expression that expresses the range of characters available as follows. Okay. First things first. Update the grammar. Update the grammar, I think symbols more specifically, because now we need to store them. So instead of having like plus or minus or cons or blah 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 blah, we'll have something completely new here instead of this. Okay, what's the next thing? Oh, no. Okay, we'll have a regular expression, which we will explain it as it comes. So let's actually copy the regular expression here. Let's copy it. What line? NPC lang, it's here. It's here. Nah, wait. This. Okay, we actually made this simpler. Hopefully simpler. So if I paste this, do this, and paste. What the fuck? paste, homie. Why doesn't it work? Ah, I need to do this. I need to remove. Where is this guy coming from? Wait. Paste. Insert. How's... Okay. Wow. So what is this doing? This is a regular expression. Let me just close it. So this is a regular expression. It uses see here it says it uses a big range specifier, which I don't know what it is, so I need to look it up. And inside the range specifier, special characters lose their meaning, but some of these characters still need to be escaped with backslashes. Because this is part of a C string, we need to put 2 backslashes to represent a single backslash character in the input. No idea what this means, but I know who knows. This is a C regular expression. Can you break it down and explain it, please? Yes. So what I assume is going on here, because I worked a bit with regular expressions, so I assume this will match against all of these, which are the lowercase letters, uppercase letters, number, underscores, pluses. Now this is I assume what is this? A special character, the minus, so we need to escape it. I don't know why we use 2 backslashes here as well. Here as well. So okay, this is okay. I know what this is. Simple enough. So then we have the plus, we have the minus, we have so these are the arithmetic operators. Okay. What are you saying? So this is a character class. The square brackets define a character class. This means it will match any single character from the set of characters specified inside the brackets. Okay. Simple enough. Any lowercase letters, any digits, underscores. This is what I want. This matches the minus sign. In a regular expression, the minus has special meaning inside character classes, so it's escaped to indicate the literal minus sign. This matches the asterisk, this matches the division slash, this is a backslash. Since the backslash is an escape character in regular expression, we need 4 of these to represent the literal backslash. Wow. Fuck me. The equal sign, less than or greater than signs, quantifier. Where's the quantifier? So this one or more. It indicates that the preceding character class should match at least 1. Okay, so we have enough variety to create variables. In my opinion, I would get rid of all the other shit. Maybe just leave the underscore, maybe a dot. But let's see. Let's go back to the drawing board. Okay, so what's the next thing? We have the symbols here. Okay. So now what I assume happens, because we replace this with regex, I'm not gonna write the whole one, but I'm gonna write az09 plus underscore minus blah 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 more than one. So because we don't have symbols, we don't have specific symbols, we'll need to look up our environment variables, which I assume here we will store stuff like len or cons, or what are some other head or eval. Here we will store our functions, which will be represented by a name, and then when we look into the environment, we will return the behavior. I assume. So we need a new value to represent functions in our language, which we can return once one of the built-in symbols is encountered. To create this new type of eval, we are going to use something called a function pointer. So what the fuck? What the hell is a function pointer? No idea. Can I look my screen at maybe at, I don't know, 266? Should be okay. So function pointers. What are function pointers? So they're a feature of C that lets you store and pass around pointers to functions. What? Lets you store and pass around pointers to functions. Confusion. A real confusion. It doesn't make sense to edit data pointed to by these pointers. Instead, we use them to call the function they point to as if it were a normal function. Again, let me reread this. Function pointers are a great feature of C. Okay, I know this, that lets you store and pass around pointers to functions. It doesn't make sense to edit the data pointed to by these pointers. Instead, we use them to call the function they point to as if it were. What the fuck? Please explain C function pointers to me as if I was an idiot. No. As if I am a beginner in C. Maybe with an example. I have no idea what they are. In C, functions themselves have memory addresses just like variables. Okay, I understand this. You must allocate. You must allocate some memory values and spaces to a function. Completely understandable. But let's continue. You can store the address of a function in a special type of a variable called you can store the address of a function in a special type of variable called a function pointer. This allows you to do what? Call a function indirectly through the pointer. I have even more questions. Pass a function as an argument to another function. Like a callback. Okay. Change which function to call dynamically at runtime. So call a function indirectly, whatever this means. Pass a function to, and I think I misspelled it here, to another function. Okay, I think I understand this. Maybe callback. And what's the third one? Change which function to call dynamically. Change which function to call dynamically. Okay, let's move this around. I can go right, I can go on the left. Okay, let's have some more empty space. Why would you use function pointers? Okay, when you want to pass a function as an argument to another function, so it most probably doesn't work otherwise. You want to decide which function to call at runtime, which is dynamic behavior. You need to work with callback mechanisms, event-driven systems, libraries like sorting functions, declaring a function pointer. To declare a pointer to a function, you specify the function's return type and parameter types, and then add this around the pointer name. What the fuck? Wait. Wait. Let me just read through this. What the hell is this? To declare a pointer to a function, you specify the function's return type and parameter types, and then add this around the pointer's name. To declare a pointer to a function. Okay, so this is the return type. This is, you specify, this is the name of the pointer or the name of the function pointer, and these are the parameter types. If you want a pointer to a function that takes two int arguments and returns an int, it should look like this. Okay, simple function pointer. Let's walk through an example to illustrate function pointers in action. Yeah, let's do this. Define some functions. Here we define two simple functions that both take two int arguments and return their result. Okay, simple enough. Now declare a function pointer. We declare a function pointer that can point to functions that take two int parameters and return an int. This is a pointer to, okay. So because C is a bit, I don't want to be politically incorrect, but I'm gonna use the word retarded. It seems that, I mean, it's not, it's a pretty cool language, but it seems the only way how you can exchange the function names here dynamically is by using a pointer reference to a function. Assign a function to the pointer. Now we assign the address of a function, either add to the operation pointer, assign the add function to the pointer like this, and call it like this. Do the same thing, call it again, So the explanation says this declares operation as a pointer to a function that takes two int parameters and returns an int. We assign the add function to the operation pointer. So, okay, so this is a pointer. Okay. I think these are all just synthetic changes, synthetic choices to be made. What the fuck is this? A function that takes, so this is a more complex use case, a function that takes a function pointer as a parameter. So this is a method. It takes, okay, so it takes a function pointer and then, wait, how is this? It's this the opening one. This is the closing one. So this is the function. And these are the other two parameters. Okay. I understand it. My huge brain. Basically broke this down and said, you can do this. And I did. So here is an example. Here's an example saying we can declare a new function pointer type called L built-in for this type of function. So type def, we are defining it here. Lisp value is the return type. Then we have this. Then we have this. And then we have this. So what does this mean? And why is the syntax so odd? So let's start with this type def. So what is the type def doing? It results in the name of the variable being declared as a new type, matching what would be inferred type of that variable. So assume creates a new type. Okay, creates a new type. What else do we have? In the above declaration, what looks like the function name becomes, the type def. This can be put before any standard variable declaration. It results in the name of the variable being declared a new type, matching what would be the inferred type of that variable. This is why in the above declaration, what looks like the function name becomes the new type name. Okay. Okay, I need to copy this. I need to ask my friend ChatGPT because the book is a bit more complex. Can you also do the same for this snippet? Please explain it. Okay, so this defines a type alias using type def. The new type alias is named L built-in and it refers to a function pointer type. So this is the alias. It's okay. Type def is a keyword in C that allows you to create an alias for a type. It essentially gives a new name to an existing type. Well, Okay. Well, this is the return type of the function. The function that this pointer refers to will return a pointer to an LL. This is the core of the type def. This is a pointer to a function. The parentheses around L built-in are necessary because without them C would interpret it as a function returning a pointer to LL. Okay, then we have these. These are the parameter types. Takes two argument, returns an LL plus. Okay. So what happens next here is that this L built-in type references the LL type and the len type. So these guys. Meaning they should be declared first in the source file. Okay. So because this guy, this is the method, because it references this, and C works in a way in which you need to declare these types before you can use it here. But at the same time, we want to put inside the LL, we want to put the L built-in. Sorry, we want to put the L built-in. So it means that L built-in needs to go before the LL declaration. And so this is something called cyclic type dependency, where two types depend on each other. So what I assume is what we will do is do something similar as we did before, in which we will declare, create a forward declaration, right? Yeah, I think I can do this. So yeah, the book says in C we can do exactly the same thing with types. So we can forward declare. We can declare two struct types without a body. Secondly, we will type def these two names, and then we will define our L built-in function pointer type. And finally, we can define the body of our L struct. Now all of our type issues are resolved, and the compiler won't complain anymore. Oh, let's go to the coding board. I think it's here, right? Yeah. So how will this go? So we create an LL, we create a len, type def struct LL struct. Why? Why is the syntax so weird? Why is the syntax so fucking weird, man? I can remove this. Now I only have a struct LL. And wait, I don't need a struct here either. and I don't need it here. Okay, I need to check why is this like this. L built-in fun. Oops. Can you explain why we did this? The book I'm following mentions cyclic types. Cyclic types. But why do we declare our types like this? Okay. Why have we lost? Why have we lost the type def before type def below and the struct and the lval after curly brace? Yeah, of course. It says here the main reason for the specific structure of the first code snippet were the struct lval and struct lenv Lisp value, Lisp environment are forward declared, and then type def is used separately is to handle cyclic types or mutually recursive types. Okay, why? So what are cyclic types? So cyclic or mutually recursive types occur when two types reference each other. For instance, in your code, both lval and lenv may reference each other. To handle this, forward declarations are necessary. So struct lval contains a pointer to L built-in. Which is a function pointer that takes an argument of type ln and lval. If lval and ln both reference each other, the compiler needs to know about both types before it can define one. Okay. So I defined structs. So these forward declare the existence of these structures, telling the compiler these types exist, but I will define their full structure later. Okay, let's see the difference. With forward declaration, a separate type def. Forward declarations for struct lval and struct lenv are provided before their full definitions. So it's a type. We're creating a new type, right? Nothing more. It's a fucking type. This allows them to be used in declarations like L built-in or pointers before the compiler knows their full structure. Before the compiler knows their full structure. Okay. Type def. After the forward declarations, the type def is used to simplify the use of struct lval and struct lenv Ah, okay. I know this. So this is for declaration. This is just defining this as this. Okay, fine. Okay, so for declaring these two guys, then uh we create aliases. Okay, this function pointer is now defined. It can be used in struct L, even though struct length is not fully defined yet. Okay. Now the second explanation, without the forward declaration, we are defining the. So it's the same thing. We are just. So this is the type def of this structure, and its alias is this, right? Yeah, yeah. Okay, I don't need to read this anymore. Even though I should. So let's continue next. Let's continue next. I think we are 1 hour in, right? 47 minutes. I think I'm gonna make it around 1 hour, 1 hour and 50 minutes. And then we can talk about some cool new tech articles and tech news. But let's continue. Let's continue. So let's talk about function types. Also there's a new value here. I completely missed it. Sorry. There's a new enum value, which is gonna be the lval function. So what do we have? We'll have lval error number symbol function should be here. Function should be here. I don't need you anymore. But function. Okay, I completely missed this. So there's a new lval type in the enumerator. It's called lval function, lval fun. And what should we do? What should we do now is create a new constructor for this type, I assume, right? Cool expressions. So lval function. Okay, I'm not looking at the book. What should it take as an input? Probably nothing. Void, right? No, it's not. It's taking it's taking the L built-in function. Taking the L built-in function. Why? Ah, okay, so it's return B. So, okay, I understand it now. I understand it now. I understand it now. And oh, this wallpaper is really bad. Are those the wait? Are those the twin towers? No. Okay. So once we break the abstract search tree into different Lisp values, we will have another box. I like to represent stuff in boxes. It makes sense. So it's gonna be Lvel function, and if you remember, all the other guys had a value to store, like the number Lvel numbers and numbers, symbols and symbols, blah blah blah. So this guy will have a function, but it's gonna have a reference to a function, a pointer reference to a function, because we can't in C we can't reference a function directly. So it's gonna have a reference in a certain memory address, right? Okay. So let's go back to the code. We need a new key. Fuck. We need a new case here. We need a new case here. Fuck. Is it here? Case function break. Why are we only breaking this? Also, is this in line? It is. Where's the print? Where's the next instance? Here. I also want to print anything most probably, right? We can just, okay, we can just print this. Why? For some reason, it does this all the time when I'm trying to write in a switch statement. One. Okay, nice. Nice, 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 nice. So, what does the book says? We are also going to add a new function for copying an Lisp value, an Lvel. This is going to come useful when we put things into and take things out of the environment. For numbers and functions, we can just copy the relevant fields directly. For strings, we need to copy using malloc and string copy. To copy a list, we need to allocate the correct amount of space and then copy each element individually. Okay, so this is something that I would like to do on my own. Maybe reference the book only a bit. So, Lvel copy. So we need to copy the whole guy, right? V. Okay, let's try to do this. Let's try to do. Actually, let me just drink a bit of water. There in a jiffy. Ah, we need to be hydrated. Okay, so first things first. Uh, 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 where's my, where are you? You're here. So, what should we do? Oops. We are copying an LL. So we should create a new one. Let's say copy. It should be a pointer value. What should we do? I should allocate some data. Most probably the size of LL. I'm gonna put the same type as the primary guy, right? Okay. And then we'll do a switch. A switch statement. Okay, so we have a switch statement here. A switch statement. A switch statement. Wait, where are you? You are here. Just check something. Sorry. Am I live? It seems like I'm okay. I'm having a switch statement here. And I'm gonna switch where's my here? And we're gonna switch based on type. Okay, for now. I will copy. So what should I do? Create a new this. Allocate how much? The size of LL. Type will be the same as the input type. Then we are switching against the type of the input. Okay, first things first. Case. LL function. So what should happen here? What should happen here? Here it says copy functions and numbers directly. So this okay, I assume. Case LL number. Break. What else we have here? Strings. Okay, strings. Case LL error. So how will this work? So I can copy this one directly, right? There's no way I can copy errors directly or symbols directly. So what should I do is I should, for errors and symbols, I should allocate memory, then copy. Yeah, it's right. I just looked it in the book. So it's gonna be, can do it like this. Okay, so it's gonna be X error. Allocating what? The length of the V plus 1. Then I copy copy, and then I break. Same thing for the other guy. So how can I copy? Let me see if I have it. No, I forgot it. How to copy for specific lines of code in Vim. For example, ranging from 183 to 187. I'm okay, so yank. I know it's yank, but it's so simple. It's so simple. Yank 183, 187. Is this yank 183, 1, 2, 3, 4, 5. Then I can put paste. Nice. Then I'm just changing here. It's gonna be a symbol. Here is gonna be a symbol. Here, a symbol as well. This guy. I'm returning the X. We have one more thing here. Ah, I messed up. Where's this guy going now? He's here. Yeah, he's here. So we have two cases. We have S expression and Q expression. So we are copying the list by copying each sub-expression. Okay. Each sub-expression. How am I copying each sub-expression? How am I copying each? So I need so the size of this times how many elements we have, and then we create a loop that goes through this, increases by 1. Okay, so this is this seems like it's a recursive function, right? Okay, I think I need a break. I need a break here. Oops. Oh, what? How? 32, 32. And I want to insert, and I want to remove this guy. I think it's gonna work now. It's not. 4 in T, okay. What line is this? 188. This. Okay, works. So we are not done with this. We are basically just setting up the code to create our environment. So how does this just work? Let me check. So if I have an LL expression, what if I have something like this? Um, if I have 1, 2, 3, 1, no, 10, 20, 30. So how is this going? So it copies the count. It's gonna be 1, 2, 3, 4. This is gonna be a separate count. Next, it allocates the size of the cell according to the count. Here. Next. But wait, how is it allocating? No, I think it's okay. It's okay. It's okay because it's okay, I think I get it. So, how long have I been streaming here? Let me check. I think an hour. An hour is okay. It's Friday. I want to relax a bit. Yeah, an hour and 7 minutes. So, I don't know. I just want to say thank you. We are gonna continue this definitely. I want to also start another book on Python because I think Python is a bit more used to C nowadays. So yeah. What chapter am I here? I think I'm on chapter 11 on variables. So there's chapter 12, there's chapter 13, 14, 15, 16, and some appendixes. So we're actually we broke the halfway line. We just need to finish this. I might even in the next episode start doing some of these other books, streaming learning some of these other books that I wanted to do. So thank you. Thanks so much for the support. I got like 5 subscribers in the last 7 days, so thank you. Let's break the 20 subscriber mark. So yeah, in the next one we're gonna do some more stuff. I think I'm getting more comfortable with this programming language. I think I'm getting better with it. So thank